and welcome to WISA's very first webinar, WISA Talks, Evidence-Based Training in Aviation. I'm Dr. Elizabeth Irving, professor in the School of Optometry and Vision Science, and I will be your moderator for the webinar today. Thank you to everyone who has joined us virtually. To begin, I would like to acknowledge the University of Waterloo is situated on the Haldimand Tract, land that was promised to the 6 nations of the Grand River, and it is the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. WISA Talks is a seminar series where we're bringing together panels of academic and industry leaders to dive deep into challenges facing aeronautics. By facilitating direct partnerships with industry, government, and academia, WISA's mission is to mobilize the research and innovation capacity of all 6 faculties at the University of Waterloo to drive meaningful and lasting impact. Our first WISA Talks will focus on competency evidence-based training research and the challenges with regard to training in the aviation industry. This aligns with the pillar of social sustainability, which I lead within WISA. Social sustainability links with training, as the future viability of the air transport sector will be linked to the competence of its workforce. Today, we will learn from industry experts about competency and evidence-based training and its current integration within the sector. We will also learn from leading academics who will discuss how their research may produce evidence to inform future training programs. This webinar will begin with a series of presentations, followed by a panel discussion and Q&A at the end. To all attendees, please keep all your questions in the Q&A tab rather than the general chat box, as it's easier for us to keep track of them that way. I would like to quickly introduce our panelists who have joined us today and thank them for joining. Our researchers include Dr. Evan Risko, Associate Professor in the Department of Psychology and the Faculty of Arts, representative on WISA's Board of Directors. Dr. Niechwiej-Szwedo, Associate Professor in the Department of Kinesiology and the Faculty of Health, representative of the WISA Board of Directors. Accompanying her is Naila Ayala, PhD candidate in neuroscience in Dr. Niechwiej-Szwedo's lab. Our industry partners include Dr. Sunjoo Advani, the President of International Development of Technology and WISA Advisory Committee co-chair. Dr. Martin Smith, who's a co-founder and CEO of Presage Group and a WISA Advisory Committee member. Mr. Mark Soodeen, the Director of Advanced Technology and Innovation at CAES, one of our WISA partners. All right, to begin, I would like to introduce Dr. Evan Risko, Associate Professor and Canada Research Chair in Embodied and Embedded Cognition in the Department of Psychology at the University of Waterloo, to tell us about his research.
Thank you, Beth, and good morning, everyone, and thank you for coming out today. So I'm a cognitive scientist. So at the most basic level, in my laboratory, we're interested in how the mind works. How do we pay attention? How do we perceive, remember? How do we reason, make decisions, act, and learn? In particular, we're interested in using the methods and insights from cognitive science to improve education and training practices. And now, through collaborations made possible by the Waterloo Institute of Sustainable Aeronautics, we've turned to considering how we can do this in an aviation context. So how might we leverage advances in cognitive science to design effective and efficient programs and training programs in the aviation sector? And there are kind of 2 important principles that are guiding our research. So first, and this is an important insight from cognitive science, and that's that we often don't understand how we learn best. So for example, when learners are exposed to a series of different methods of learning, so let's say rereading material or testing themselves when they're studying for some upcoming test, they'll often fail to recognize which method will lead to the best retention of the to-be-learned material. And the answer is testing. But It's hard sometimes when we're reflecting on our own learning to understand what methods are going to lead to that kind of long-term retention that we seek in our education and training programs. So an important lesson that we take from these kinds of insights is that we can't rely on our intuitions to make decisions about the relative effectiveness of different methods of learning or instructional practices. And we can't do this as instructors or learners or instructional designers either. What we need is an experimental or evidence-based approach to understanding how best to design training regimes. So the second principle is that learning is a complex skill, right? Learning isn't just learning. Learning ends up being made out of a number of different kinds of features. And this is going to be true of any complex skill, and particularly those in the aviation industry. For example, learning involves paying attention. Learning involves being motivated. Learning involves being kind of metacognitively aware of our learning. We have to know when we're not understanding things and when we're understanding them. The approach we take in the laboratory tries to recognize this fact in that we explore these various domains or different facets of learning and how they're affected by different learning practices or different instructional practices. For example, we might compare two different instructional practices, let's say a standard lecture-based approach to a more testing-based approach in terms of how each might impact how learners can sustain their attention to the material. Do learners' mind wander more when using the standard lecture-based approach or a kind of testing-based approach to training? So we can also ask how each of those methods impacts how well learners can monitor their own learning. Do they know when they're understanding the material and when they're not understanding the material? Does this differ across the different methods of instruction? If it does, how does it? So we hope to be able to put these insights together with the results in terms of how each instructional method might impact learning to inform decisions about how to best design those learning experiences so that they're both effective and efficient, and so that we're using our training resources effectively. So we think an evidence-based approach based on experimental comparisons of different instructional practices that's grounded in cognitive science provides a critical tool in an effort to optimize learning in general and in the aviation domain. And we hope our lab can contribute a little bit to that overall effort. Thank you.
Thank you very much, Dr. Risko. Next up, we have CAE's Director of Advanced Technology and Innovation, Mr. Mark Soodeen.
So I thought I'd start by sharing with you today some of the challenges we face as a training provider, both in the aviation space as well as medical. Some of these challenges are certainly not unique to our domains. It's about learners and teachers assessing the learners in terms of the level of mastery. So some of these topics here are well beyond the aviation industry, but still challenges, of course, for us. So the first one that I'd like to share with you is just a general question that airlines are going to be facing as this data becomes available, is how do we drive the insights that we're gaining through this data coming from the training world. So coming off of full flight simulators or some of the lower level devices, and how do we correlate with what the airlines are seeing in the operational world? In the end, the target is to improve safety and efficiency in an airline, and how does this training data that we're driving or deriving out of the training world help improve those two aspects in the operation of an airline? The next a challenge, and it's a challenge that's been in our industry, and I think beyond our industry for decades, is how do we standardize instructors? In other words, delivering the same content, how can we guarantee that the evaluation is also occurring in a fair manner so that students are not unduly penalized, or the opposite end, not getting the feedback that they really need to take the learning and translate that into operational usage. So how do we help how do we standardize our instructors and by making data available to them in a clear and concise and efficient manner. The next is, like any technology company, technology is sexy, but the real challenge is how do we bring that technology and blend it with the learning sciences? In other words, find the right way to deliver the content, measure the outcome, and don't get too lost in the widgets that we require. So a little bit change the focus and start from a learning perspective. And with competency-based training, we're going to derive deeper insights now into the behavioral world. So what new technologies are available there to support this trend? And last but not least, with the change in way people do learn today versus 10 years ago versus 20 years ago, how can we drive more student-centric learning as opposed to group level learning, and can data support this? So those are the 4 challenges I'd like to share with you today that we see. So very, very high level from an aviation or an airline perspective, we have sets of backlinks. We have a vast amounts of data. The top box titled safety data is representative of some of the data sets coming from the airline operations directly, such as flight data, recorder data coming off of things that you'd know today as a black box. They also line audits, safety reports. So you have lots of structured, unstructured data coming from an airline. You have on the far left training data coming out of the training of the crews that occur on a recurrent basis as prescribed by the regulatory agencies around the world. And new today is the emerging area of biometrics, looking at things like scan patterns, cognitive workload, and all of these data sets are embedded insights into the individuals as to their mastery of various skills or an understanding of safe and efficient operation of an aircraft. And how do we take that data and update our learning content and deliver that content in a personal way and drive other insights through this data that would then lead to improvement in safe operation or improvement in the delivery of an assessment of training by helping the instructor population. So this is peeling the onion a little further to give you some insight into the kind of data sets that now are becoming available through evidence-based training. For example, in the top left corner, you have the color-coded competency grading across the bottom scale, which is the number of flight hours. So you can see that there was a dip, an overall dip in the competency evaluation of the crew population in the region of 1,500 hours. So this is then a marker that you can use to delve deeper down into what is it that's causing this dip at this point in the flight hour span that you're seeing there. Also available to us through the evaluation and skill based testing as part of EBT. Any grades are below 3 or above 3, you then obtain some visibility into the observable behaviors. And because they're behaviors, you can now task specifically teachings to address those behaviors, whether they're positive or negative. Some behaviors you wish to encourage, some behaviors you wish to change for obvious reasons. Also, some other data sets we're deriving directly out of the training devices. For example, we monitor the crew's applications of procedures. So the timing, the order in which, for example, engines are shut down or monitored, or passenger evacuations are conducted, all this can be captured in a report card and made available to the instructor. We can look at situational awareness now through emerging technologies such as eye tracking. And of course, we can address some of the competencies, flight path management and automation by monitoring specific flight parameters to monitor the skill sets of the crews conducting specific maneuvers. So very rich data set now becoming available to airline training managers and instructors. Thank you very much. I think that's the last slide.
Thank you, Mr. Soodeen. Very, very interesting data sets it looks like you have there. And now it looks like it's my turn. As you've already heard, I'm a professor at the School of Optometry and Vision Science. Next slide. I am the principal investigator on a New Frontiers in Research Fund grant, and that grant is entitled Innovative Pilot Training and Evidence-Based Vision Standards for Aviation. My co-investigators are Suzanne Kern, Shur Shao, and Iwa Niechwiej-Szwedo. What we're planning to do in this grant is define specific competencies for pilots, for example, in takeoff and landing situations. And we're kind of looking at what the details of those competencies would be. The plan at the moment to do that is to have focus groups of experienced individuals and, roundtable discussions of what these competencies would be. The second aspect of the grant is to characterize gaze behavior, vision, and the interaction of gaze behavior and vision. And so what we're looking at, again, in takeoff and landing situations, what people look at, how good their vision needs to be, and if vision is affected, does that in turn affect gaze behavior? And then we're looking at how these things interact with the competencies that have been defined in the earlier part of the project. We plan to look at different degrees of difficulty, such as weather conditions in our simulations, and we plan to look at different levels of pilot skills. So novice pilots, intermediate pilots, and expert pilots. And we're expecting that there may be differences, for example, in the amount of vision or the level of vision that is required, or changes in gaze behavior as you have more experience. Finally, we plan to take all of the things that we learned in the first two aspects of the project and try to build computational cognitive models. And the goal for this is to try and create a more objective measures. Well, the goal for the whole thing is to try and create more objective measures of measuring and evaluating and determining whether or not a pilot is competent to fly their plane. Next slide. My particular part in this involves justifying vision standards. At the moment, vision standards are quite arbitrary, as are driving standards for that matter. And this amounts to a couple of things. One, it's discriminatory because if you don't need vision and you're being required to have something, you can't do something that otherwise you would be perfectly capable of doing. It also decreases the pool of available people. And we started looking at this prior to COVID, and the aviation industry was looking at, the potential for severe pilot shortages. Anyway, so that's how it started about, and we're looking at ways to increase the pool and increase retention, because of course, what we know about vision is that as we age, it doesn't get better, it usually gets worse. And so pilot retention would be an issue with respect to their medical part of their licenses. The one thing I wanted to bring to everyone's attention today is that there's more than one aspect of vision that we should be considering. And usually we think of vision as visual acuity, and you can see the pictures on the left. We have you read the eye chart, and if your vision is blurry, as shown in the picture beside it, you can't read as far down the letters. And that's really only one aspect of vision. We also want to look at things like contrast sensitivity. So if you look at the pictures there, we have two pictures, one which is high contrast and the other which is degraded contrast. But what happens is the detail, there's no change in the detail, but it's still harder to see because of the reduced contrast. So that might happen in things like whiteout situations, those kinds of things. The third aspect is what is known as stereo acuity, and it is fine depth perception. I don't know if you'll be able to or not, but if you can actually cross your eyes and fuse those two black dots that you see there, you should notice that the balls actually show up either, depending on how you do it, either in front of or behind the plane of the rest of it. And finally, the visual field is really important. And you know, we're talking about earlier, we're talking about situational awareness. And of course, if your field is constricted, like the tunnel vision type picture we have on the far right, it's going to be pretty hard to be aware of things that you can't see in the first place. So we will be evaluating visual acuity, contrast sensitivity, stereo acuity, and visual fields in this process. Thank you. Our next speaker is WISA Advisory Committee member and co-founder and CEO of Presage Group, Dr. Martin Smith. Marty.
Okay, thank you, Beth, and hi, everyone. It's a pleasure to be here. So I'm just going to give you a high-level description of how Presage has leveraged evidence-based data and information, and how it's really critical to optimizing pilot decision-making, ultimately compliance. So our research leverages evidence-based data, and we always want to look at the lived experience of the pilot. As a pilot myself, I became very sensitive to the difference in comprehension levels, if you would, of the pilot population understanding more complex cognitive processes versus how they simply live flying. Those are two different domains. We may talk about that a little later because it does affect the value of evidence-based training. But in this example that I want to share with you, one of the major research initiatives we have undertaken over the last 10 years is to look at go-around non-compliance. And in the industry, the compliance rates for stable approaches, about 97% of all approaches to landing are stable, which is great. 3% are not. And that translates to about 80,000 landings a year are actually unstable. And landings represent, approach and landing accidents represent 2/3 of all accidents in the industry. So this is something we want to get right. We want to be able to land the aircraft safely. We have a policy for that. That's a go-around policy. And we have a 3% compliance to that policy. So this is clearly a problem within the industry. It's been this way for 4 decades. Further compounding this problem is the evidence suggests that the industry has no guidance for the touchdown zone, and in particular, instability through the touchdown zone, which an instability would be when the aircraft is drifting left or right of the center line under certain visual conditions that may be a bit more challenging. What are the pilots referencing in terms of how far can that drift go until it becomes threatening to the aircraft safety, where the main landing gears are actually off the side of the runway. And then we have floating is another example where the aircraft floats down the runway because of particular changes in atmospheric condition, winds, et cetera, through the touchdown zone. So right now there's no guidance for that in the industry. So we've been working with the industry, commercial side, mainly over the last 10 years. We deploy our research study, and we're looking at the psychological, operational, and cultural drivers for non-compliance to this go-around policy. We will consistently develop, based on our research, new policies and procedures. And subsequently, we'll take these new policies and procedures and train for them, test for them. We'll do validation testing with our airline customers in the simulator. We have a matrix, Presage has developed a matrix of 400 different approaches, where in these approaches, we are manipulating the simulator environment to recreate an instability, but to do it in a way that it reflects the lived experience of the pilot. These instabilities typically occur below 1,000 feet that we're going to trigger. And they are subtle. They are nuanced. As a footnote, and Mark can speak to this a little later, I'm sure, simulators are not designed for this type of requirement. We are injecting essentially requirements for an instability that on the software side, simulators are not designed for it. It requires sophisticated training for the actual sim facilitator and the instructor in order to get the instability correct that we want to train for. A real challenge to the industry. The value of taking these types of simulator tests, if you would, and replicating the lived experience of the pilot is it allows us to train for priming the psychological pump. This has been a key aspect of our research over the last decade. When it comes to decision-making in the moment, pilots are much more likely to be compliant when they're able to prime the decision-making pump. So you'll see the next bullet there is dismantling the goal, which has historically been the goal of we have hit the limit, we need to follow a procedure, a compliance requirement. So when the goal is the limit, that's a problem. You can see on the right-hand side an example of the touchdown zone where we have tried to manipulate through new training based on our research, where the goal and the limit now have psychological space, time and space to work with. We have implemented a shared mental model for crews through the touchdown zone, where the goal is to land in the green zone. But if you don't land in the green zone, there's a warning where the pilot monitoring will prime the psychological pump for the pilot flying, that you are floating, 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 and there's a limit pending. We are approaching a limit. That creates a psychological readiness to act. So we've been doing this research and deployment with close to 30 airlines around the world now, modifying and providing guidance through the touchdown zone, all of it based on evidence, okay? Data that we have collected and we have moved into the simulated environment for training and testing. So next slide. This is an example of, and this is kind of an accidental consequence of our research, but our airline customers are realizing some significant return on investments. Ultimately, in this particular space of improving pilot decision-making and landing accuracy in the touchdown zone, that there's a sustainability factor involved here. So improving go-around compliance when required, that's fewer go-around. That's going to equal less fuel burns, increased safety. Go-arounds have their own risk. Operator data indicates as much as a 20% reduction in brake wear, fewer brake overhauls, replacements, reduction in waste, new material costs. This is a very important finding, the next one, the significant reduction in tire wear, hard landings, and tail strikes. Again, we're manipulating pilot decision-making to land in that green zone, reduces the environmental impact in terms of rubber replacement, steel, titanium, aluminum, all of these other metals, materials. We are extending the equipment life of these products. Last point here is requirement for reverse thrust is significantly reduced in the touchdown zone when you create improved decision-making accuracy. There's less noise, less fuel burn, less flap damage, and longer engine life. One of our airline customers that has over 500 aircraft is modeling that they can extend the engine life upwards between 6 to 9 months. So that is a huge has a huge environmental as well as cost saving outcome. So that's it. That's just a case study giving you an example of how we leveraged evidence-based data, but also how it can be deployed in a training environment. Okay, Thank you.
Thank you, Dr. Smith. Looks like there's great opportunity for sustainability coming from your work. Our last researchers are Dr. Niechwiej-Szwedo, Associate Professor of Kinesiology, Faculty of Health, and our next one is Naila Ayala, a neuroscience PhD researcher at the University of Waterloo.
Okay, good morning, everyone, and thank you for the introduction, Bev. So I'm a kinesiologist, and my core interest is to develop a fundamental understanding of how the brain controls visual motor behaviors. So I'm quite a novice in the field of aviation, but I think that our previous work and expertise that we have in our lab could be applied in the field of aviation. So we have previously studied visual motor control, eye-hand coordination. We're looking at gaze behavior during motor learning. And we have also looked at eye movements during tests of executive functions, including inhibition, attention, and problem solving. So considering what the pilot has to accomplish to fly the aircraft safely, I think that the domains that I just mentioned are all relevant and important. So I'm very excited about the potential opportunity to work with this team and contribute in this field. So just very quickly, a brief literature review on the topic of eye movements in aviation revealed quite a few studies have been done in this area already. So studies have been assessing pilots' behavior across different tasks. And what this literature is revealing is that eye movements can provide insight into three areas. One, that's the mental state of the pilot, so their level of anxiety, stress, and workload. Two, situational awareness. So we can get a measure of where the pilots are looking, where are they deploying their overt attention? And three is expertise. So there are distinct changes in eye movement patterns that are associated with pilot expertise. And this is the area that we are interested in. So we have some preliminary data on this, and Naila will share with you some of these data on the next slide. This really is our first project. And what we are looking here at is to establish the metrics and outcome measures that we could use to differentiate between novices and experts. And why we want to do this is to develop gaze intervention studies. So if there is a scanning strategy that differentiates between novices and experts, can we exploit that to develop training protocols that are aimed to optimize scanning patterns? And this could have some utility for competency-based training. So I'm just going to give it over to Naila to talk about the findings.
Thank you, Eva. Good morning, everybody. So like Eva was saying, we have these two videos here that I'm very happy to show you from our preliminary data set. And what we're going to be looking at specifically, most thanks to WISA for allowing us to recruit these pilots that have a wide range of experience. And so on the left, we're shortly going to be playing this video of an expert pilot who's been working with a commercial airline for quite a few years now. And then later on, we'll be starting this second video of a novice pilot who's at the very early stages of their training. So they're in their ab initio stages there. And what we're able to see here is this overview or a play-by-play of where that individual was looking as they were performing this task. And so we had them land in this low fidelity flight simulator using a computer. And so what we're going to be able to see here we go, is that they scan their environment quite a bit. And it seems to be breaking down into two main stages where they go through this configurational stage and they're looking at a wide variety of the gauges within the cockpit. And then once they've established a stable approach, which was touched on earlier by Marty as being a pretty crucial thing to do for a safe and also optimal landing, they then switch into this phase where they're doing this cycle of checks. So they're constantly looking outside into that area where the landing strip is, and then shifting their gaze back inside to one or two of the gauges within the cockpit. And they're cycling through that quite frequently for the duration of the trial. And so once we move over to our novice video, what we're going to see is something very different. And what we see here is that they actually become quite fixated on what's going outside of the cockpit, namely the landing strip there. And so they don't actually look at many of the gauges within the cockpit nearly as often or nearly as extensively as the expert pilot does. And if they do, it's quite infrequent throughout the entire trial. And so you can start to see how that does play on how they are able to take in information from their surroundings and eventually play into their level of performance or things like their situational awareness. And from these videos, what we're able to actually take is these network models. So there's going to be two figures that pop up right underneath these videos soon, which will allow you to get a very quick overview of how we're able to characterize some of the relationships we see or some of the patterns that emerge through these eye patterns and eye behaviors that happen. And what we're able to quickly take away from these two pictures below is that they differ quite robustly in their strength and in the degree to which they span all of these different areas of information. So you can see in the expert panel there that these relationships go to a lot of the different gauges within the cockpit, and the strength of those relationships are much more robust compared to the novice pilot. And so this becomes one of the main sources of information that we're able to pull more analytics from that give us more of an insight into what the pilot is thinking, and allows us to also try and quantify what the aviation industry deems as these soft skills, which is still somewhat hazy. And it's really hazy because they're not readily observable as some of these other performance measures are. And so we're very happy to be able to start to, put a number to some of those softer skills, which really include things like your ability to process information, your ability to multitask, and plays into things like situational awareness, which all do have a big impact on performance. And so moving from this low fidelity study, we're really excited to see how this data then evolves into the high fidelity simulator, because it does provide us with a lot of the foundational answers that will then support and guide really the novel training practices that we hope will one day be used to train this next generation of pilots. Thank you.
Thanks very much for that. It's very exciting to see the first kind of data coming out from WISA. Last but certainly not least, we have WISA's Advisory Committee Co-Chair and President of International Development of Technology, Dr. Sunjoo Advani.
Thank you very much. Nice to be here today, and good morning to everyone. I'm in the Netherlands, so it's almost evening here. I want to first, I will discuss the training challenges, but I just want to start by first reviewing some of the competencies that we're talking about. You see, evidence-based training is a methodology of competency-based training, where the actual generation of airplane influences the type of training that is delivered to the pilot. Now, why do we do that? If you think about it, the old generation of airplanes like DC-8s and 707s, they had a lot of these clock dials and displays, and those pilots were aviators. Today, the pilots of modern Airbuses and Boeings are more like automation managers. So the motivation for all this evidence-based training was, why should we be training today's pilots using the same techniques as before? Now, if you see on the left, you can see the competencies of the pilot. On the right-hand side, that column are the instructor competencies. Let's look at some of those competencies. You can see one of those most important ones. Well, there are some technical competencies, and like was just said, there are non-technical competencies. One very important one is problem solving and decision making. We've been discussing that earlier. Now, think about this. How do you make decisions? It's not always something that you just do it. It's part of your internal process. It becomes innate, but it's a very, very important central competency. And when we assess pilot competencies, we can look at the input and we can see the output. It's very difficult to assess the process that takes place in between. if you think about decision-making and how it affects you, a good outcome based on good decision-making, it will lead to a good outcome, but an improper decision-making can lead to a negative and disastrous outcome, right? So if we go to the next slide, please. What I wanted to explain here is that the old way of training was based on qualifications, regulations. So a number of hours of study, number of hours was practice were given to the trainee, and you hope for the best. Go to the next slide, please. This is what competency-based training is about. You have a training program, and you have an instructor, an assessor who is assessing the outcome. It's outcome-focused training, and it provides the graduates with the competencies in order to be safe, effective, and efficient. The problem with all of this is not just what is the student looking at themselves, but what is the instructor doing? We come back down to the instructor's competencies. So if you'd go back to my first slide, 2 slides back, please, Valerie. Yeah, there we go. You can see here on the right, the instructor has several very, very important tasks. The instructor can see the inputs and the outputs, but not the process in between. I see that as one of the biggest challenges because it's the perception, the analysis, the decision-making that takes place in a pilot's mind that is very, very difficult to capture. The instructional delivery, again, the instructor can only see what is visible and what is obvious. Even with gaze tracking, you can see what a person is looking at, but how are they perceiving that data? How are they processing that data? If you think about the interaction with the trainees, this is also very important to understand. How did you make those decisions? What were those decisions based on? And the last one, assessment, is actually where it closes the whole loop in this whole competency-based, evidence-based training, because the assessment of pilots is critical to their career. There's no other industry in the world that is more scrutinized than aviation. And there's a reason for that, safety, right? But we also have to look at the inter-rater reliability, in other words, the relationship between the assessments of different instructors. So I see these as some of the challenges, and I certainly hope that WISA and the team here will be able to address some of these and learn from the real world, what is going on and how is this training being developed, deployed, and what are the challenges in the training. I think I've covered pretty much everything here. And the last point is training itself has not changed very much, but the way that we train, the methods of learning have changed. Today's pilots, as I say, more systems managers than before, learn from a different type of process as well. They learn much more from advanced modern technologies, and it's not just from the books and from the classroom and the simulator. There are many more sources of information that pilots use. And so I think we need to take all of these factors into account in the development of better EBT techniques and better tools to help the instructors to do their job in a more consistent and accurate way. Thank you very much.
Thank you, Dr.
Technical issues, but we'll get to that later.
Yeah, we can do that as part of the discussion, right? Thank you, Dr. Advani, for that. And now we're going to move on to the discussion portion of our webinar. First of all, thank you to all the presenters. Very interesting topics that you're all talking about. We have quite a lot of questions today, so I'm not sure if we're going to be able to make it through all of them, but let's give it a go. Following on with what Dr. Advani was saying, we were talking about challenges for evidence-based training. What do you see as being the advantages of it. So why, you said change had to happen. We had to train people differently. So what do you see as the advantages of it?
Well, the advantages of this whole approach is that it's not just the same rote type of training that was driven purely by regulations. So in other words, you have to train these particular tasks, these particular, let's say, inputs. It's more based on what is the outcome. Are you able for this particular generation of aircraft to deal with the types of systems, the type of interaction with other crew members? All of those competencies have to be assessed based on the current generation of the aircraft, and even going as far as the actual aircraft type. And that's the advantage, because how we train should continue to evolve. And it hasn't until now, until EBT came along. And so it's data-driven, competency-based, and bringing everything more closer together.
Mark or Martin, do you have anything you want to add to that?
So certainly, my thoughts on that have to do with just the example I presented, which is the Presage matrix of 400 different types of approach scenarios. So this is, I think, a best practice example of how to use evidence-based data and to be able to use the high fidelity simulators that can be manipulated in the way that reflect the lived experience of the pilot. So these are real scenarios that will be developed that happen very, very infrequently within the experience of a pilot's lifetime even. But this gives us an opportunity to actually expose them to these types of risks and threats during the approach phase of flight. We could never do this without, one, the evidence, the data, and then the empirical testing within the simulator environment that provides tremendous bandwidth on options and differences in terms of risk scenario approaches to landing.
Sunjoo, do
Yes.
you had to comment?
I really like that one comment that you just made, Martin. Mark, just a moment, please. You'll have to unmute as well. The point here is that that example that we saw was a very nice example of the approach to Toronto Island Airport. That was on a perfectly beautiful, calm day, no winds, and so on. Now, how would that same experienced pilot react in a different situation? Let's say there's turbulence, crosswind. Is that crosswind beyond the limits? Can you still use that runway? There you go, decision making. Forget about major system failures. Let's go back to the basics and see that they are actually able to make the right decisions and apply all of those competencies. That's why we don't simply call them skills, in an integrated way and perform the task. And we look at the outcome. And then we can do it under different conditions, varying conditions, vary the level of challenge and difficulty, and see how does that process actually take place. But again, I keep driving it. I'm driving the same old record. It comes down to the instructor.
Yeah. So that's a good point, Sunjoo. When we look at training, what we're not necessarily focused on evidence-based training as a topic. What we're focused on is the outcome, and what we're targeting is to create a level of resiliency in the pilots, in the crew that are training with us. And resiliency means that we are giving them the tools as embodied in the competencies and underlying behaviors to deal with situations that will arise that no one can predict. So in previous training methodologies, you were considered an expert when you could do a one-engine takeoff consistently. And to Sunjoo's point, what happens if I were to change certain variables? As part of that exercise, would you still demonstrate the same level of mastery? And evidence-based training overlaid over competency-based training and assessments and implementation that gives us the data to understand the mastery at an individual level and create actionable items at an individual level that move towards that level of resilience. That's where we want to go. All right, so that's how EBT helps us with this journey.
Exactly. Yeah, that's a very good point that you make, because resilience is, I learned this from a University of Waterloo prof. He said, look outside. Resilience is that tree bending in the wind, and when the wind stops, it bends right back. That's resilience. And that's what we want a pilot to be able to do. Here you have a situation that's a normal, beautiful, sunny day. Birds are chirping and there's no wind, and you make a perfect landing. Now you have a situation that for which there is no existing procedure. You have to now base your decisions on your own skills, your own competencies. And you can see where I'm going to. That's the part where resilience comes in. So I really appreciate you bringing that in, Mark.
I'm actually able to jump in here. That's going to be where our next studies really take us. Is we did some early stuff in the study that I just showed everybody here, where we did manipulate the crosswind. It was quite significant. And I'm pretty sure it was almost at the limits of what the plane itself was able to handle. But I think when we move into the Alston simulator that we have on campus now, dedicated for research, we're really excited to see how we can look at not only the gaze behavior, but then the actions of the pilot and how that affects the state of the plane, all side by side, so that we are able to kind of study and characterize and hopefully detect these different phases of what's going on as somebody is trying to deal with all of those different scenarios, right? And how they can be better prepared to deal with them, or how we can better train to that, and trying to pinpoint where that decision-making process kind of takes place and when it breaks down.
Yeah.
So that's one of the next things that we will be studying that we're excited to see.
Very exciting, yeah.
So it sounds to me like, our panel is in agreement that this is a good idea. Some questions have come up from the audience. So what government interaction involvement has occurred with evidence-based competency training? At the end of the day, their support is critical to the adoption of new methods. And along a similar vein is, what would major airlines think about this? Would they agree with this type of training if it's used to justify a reduction in hours of requirements for licensing? So Sunjoo, do you want to start?
Well, I know a little bit about the regulations. I'm involved quite a bit in that aspect of it. Competency and evidence-based training has now been published by ICAO. It's been adopted by EASA, and it's in place. So airlines are quickly adopting to this. Now, Transport Canada is also in the process of adopting and making changes accordingly, to the best of my understanding. Other regions of the world will also start to do this. The American equivalent of evidence-based training has actually been around for quite a long time, and that's called AQP, the Advanced Qualification Program. And it was the predecessor, and there's some differences between the two. We don't need to go into those details, but this has already been understood and adopted. Now, the difference, the main benefit of this evidence-based training is the integration of these competencies with the evidence based on the generation of aircraft. So I don't see any issue in adaptation. It's a matter of process. And EBT has been pretty well defined. Now it's a matter of training the airlines how to adopt it, how to implement it, and training the instructors who deliver it on how to do it properly. Those are going to be challenges, believe me.
Mark, I see you nodding your head. Do you have something you'd like to add to that?
Yeah, so I can confirm some of the observations that Sunjoo has just shared with you. The adoption rate in the EASA world is very high. the airlines understand the value of it. They also understand that the target audience is also learning differently. They also understand that, you know, shorter learning cycles, shorter than what's currently given through the regulations of twice yearly, are going to actually lead to a greater level of resiliency in their crews. In other words, the best time to learn is right after something happened, not 6 months later or 1 month later, because it's now part of your recurrent training. So we need to get experiences, personal experience, operational experiences to the crews as quickly as possible. So I think EBT is the method to do that. And I think that's why the airlines are embracing it. They understand that. Of course, there's always a cost associated with any change in methodology, retraining of instructors to assess behaviors which may not come naturally to all, and it is not an easy thing to do. But I think the industry in general understands the value, and I see actually a lot of movement towards non-regulated forms of training, even, which in theory are costing the airlines also money. So I'm not an airline, we do work with them, but there seems to be a mindset change going there and not looking for business cases at the outset. So it's very encouraging.
That is very encouraging. Our next question is, how can research and industry collaborate to support training the next generation of aviation professionals? And I was wondering if Evan might like to speak to that first.
Sorry, Beth, how can research in industry?
So how can research and industry collaborate? So in your mind,
Oh.
how do we collaborate to make it better for the next generation of aviation professionals?
Well, I think, you know, institutions or efforts like WISA is a good start. And I think the first step is just developing those relationships where we can, let's say as university or academic researchers, tend to be focused on their problems, can sit down with industry leaders and work together to figure out a common ground where we can answer questions that are going to be relevant to that industry's goals, and adapting our methods, and you know, taking a step towards translating some of the insights that we might have in the past to these novel contexts. And I think it really is about two different groups of people with the same goals kind of coming together to realize that they have shared goals and trying to trade on each other's expertise to move us forward.
Martin,
yes.
do you want to add to that?
Yes, I would actually. And I'm speaking to this from the kind of flight department side of an airline. So when you look at the makeup, the characters within that flight department, what you will see is a complement of mostly men, mostly pilots. Maybe that complement is made up of some engineering backgrounds. But what you have is a bias towards flight operations. This is not a group who are neuroscientists. They are not cognitive psychologists. They are desperately lacking in that education, that sophistication of thought, that knowledge transfer. Because historically the personality type and landscape has been mostly the masculine personality type, there's been a resistance to reach out and engage, step outside of their own silos. I would submit to this group and the audience that in the last 10 years, that is definitely changing. And there's an appetite, there's a readiness now to engage the academic research community, but there is a long way to go. I have sat in flight departments where executive decisions around standards, so what kind of training, the standards will influence the content to be trained for, really reflect a kind of dart throwing, that they're relying on a subject matter expertise to mitigate an operational or flight risk, but it's in the absence of this kind of intellectual knowledge transfer, the, just developing a more intimate relationship with research institutes. So the timing is absolutely critical. Evidence-based training is a platform for that meaningful exchange of information to happen. So timing is perfect.
May I just add one quick comment to that? Martin, you are absolutely right on with that. And you know what happens very often? Regulations come into place and they say, oh, we don't have time for research. Researchers want to do something relevant for regulations, and regulators say, oh, we're not onto that yet. Yeah. And so there's always this mismatch of like two airplanes at two different altitudes crossing each other, and they don't talk to each other. And this is a great opportunity. This is how I see bringing that together, because you have to identify who are all the stakeholders. The researchers also need to understand that. And that's what our role is as an advisory committee, to help WISA to become wiser and to know what's going on out there in the world, but to let the world, like we're doing today, know what WISA is capable of doing and what this can mean to, their actual implementation of these concepts. There's a lot that can be gained here.
Great, thank you. I have a question from one of our participants today. Considering the increased pressures on pilots, such as the global pandemic health risks, general industry downturn, and requirements to maintain on-time performance to ensure airlines return to profitability, what is your view on increased emphasis on mental fitness for flight as an area of focus for competency-based training?
Well, that's, if I could maybe share some of my own thoughts on that and some of the research we've done with a few of our industry customers on this. If you look at the CDC data, that upwards of close to 40% of the general population, which would include the pilot population, is going to meet the clinical threshold requirements for anxiety or depression in the last year. And these numbers hold strong. So there is an undeniable mental health issue that is landing in the flight deck. You can also layer on top of that the personal anxieties of extended family. Who are you flying with? Often in larger airlines, you'll be flying with an individual you may have met for the first time. So there are these very multifactorial variables in this equation that ratchet up, and we see it in our data, the stress, the degradation in decision-making and situational awareness. And Ayala has been reporting, about a year ago at this time, the number of incidents and accidents, approach and landing, there was some significant accidents. So it's a very real issue for the industry. It's also a very delicate issue. There are pilot association contracts that limit disclosure of mental health issues. As a clinical psychologist, there is nothing more threatening to a pilot than compromising their medical. They are only licensed to fly if they have a medical. And the disclosure around mental health issues is a very serious issue. That said, again, we're back into the simulator training environment. If an airline, for example, can capture the data on where that degradation is in decision-making and performance, that evidence can now be leveraged in the simulator for training, for example. And there are certainly airlines that are doing that.
So, and I just have a personal question here, and that is, in that vein, would there be mechanisms for I know, regular evaluation. So it's kind of like everybody has to do some kind of evaluation for the status of their mental health. And as opposed to, I guess what I'm looking at is ways of uncovering things that people are trying to hide because they're like, their livelihood depends on it. And whether it's mental health or whether it's, we have the same thing with vision, right? So
Sure.
their medical standards go if they can't see, and there's all kinds of ways to try and get around the tests that we do. And
Well,
is there something in this along this line, right?
Yeah, so most airlines are pushing out, and they have for the last, since COVID, have been the fit to fly, your own personal inventory on your readiness for duty, your fitness to fly. And that does include a kind of mental health checklist. Part of the problem, though, with you, when you look deeper into depression, for example, self-regulation, self-monitoring, self-evaluation is compromised as a byproduct of that. So now you're into what many of the airlines are doing is a peer evaluation, where you're cross-checking each other for fitness for duty, which is another way to advance that kind of self-diagnostic test, if you would, that others around you can tap you, can have a quick Q&A with you about your readiness. It's a very complicated and multifactorial issue. It really, really is, and a challenge for the industry.
Absolutely. All right, changing gears just a little bit here. What role might biometrics technology and AI have in observing and scoring human performance in evidence-based training? I don't know, Eva or Naila, do you perhaps want to speak to that? First, we'll give the rest of them a chance in a bit.
Sure. I guess I can speak a little more about some of the stuff that we've already started to see in our data so far. It is quite robust how the data is coming across in just eye movements. We haven't even started to look at things like, pupil dilation or how other things related to the visual system can be a great indicator of how we can measure not only performance, but anxiety, like something that stresses the system that maybe because of weather or anything like that can start to speak to, the level of compliance that the pilot, or not the level of compliance, but the level of the competency that the pilot actually has, and how critical that is actually in some of the novice years, and trying to not only develop that as a quantitative measure, but then use that as a tool to, train. I think it is already proving to be a pretty promising tool in that it allows us to quantify when people start to break down in their ability to process information and how that then impacts their performance. So for instance, in our eye measures that we've been looking at in this industrial study, when we start to talk about, simple things like crosswinds, not emergencies, but just, differences in the weather conditions that are being thrown at some of these pilots, we see how some of the more experienced pilots are able to deal with that by using some more structured or some more strategized eye movements, so that they're still able to process the information in an effective way that allows them to land properly. Whereas when we look at some of our intermediate or novice pilots, we actually see that they jump almost into the state of stress, where their eye movements are more erratic. And some of the things that we're able to pull from that is that it's like they're looking without actually processing the information, right? So they may be scanning everything around them, both outside the cockpit and inside the cockpit, but a lot of that isn't actually being processed. So none of that helps them. That just increases their state of arousal and leads to more errors when they come to their final approach.
If I can just ask a question on that, and maybe Evan can answer this better, because our experience has been, and we do a lot of simulator monitoring and evaluation, is the whole executive cognitive functioning, so that you can, the eyes may be looking at a certain space, but there is a meta-analysis that's going on at a much higher level. And, that kind of, I do it myself, I'm staring at into space, literally, but there is complex executive functions going on there that, you know, the eye tracking may be a way to peer into that, you know, but how to unpack that more complex. And we've attempted to do that in the simulator with instructors to stop a simulator and say, what are you thinking right now? You know, literally, where is your head to unpack that? So I don't know, Evan, if you have more thoughts on that higher order executive functioning.
Yeah, absolutely. So I think it would be referred to in the field kind of indirectly as looking without seeing.
Yeah.
You can see someone fixated on a region, and if they're, let's say, attending to something internally, that they wouldn't detect a change or something along those lines. So yeah, absolutely. Where you're looking overtly, where your eyes are, is not always where you're attending. So you can very easily look without seeing.
Okay, we're coming close to our time here, but I have another question it's a bit different from what we've been talking about here. And that is this approach also suitable for new aircraft designs like electric vertical and takeoff and landing, so eVTOLs? So can we use the same thing for all kinds of aircraft, or is this?
I can kick that off.
Okay.
So what we're seeing today is there is currently no regulatory framework in place to certify eVTOL flight crews. So there's a tremendous movement all over the world to try to understand how an eVTOL differs from you know, fixed wing and rotary wing aircraft and their respective regulations, and how potentially those regulations could be complement one another bundle to create an eVTOL. But the starting point today for eVTOL is the person entering into that is already a commercial pilot, right? So that you're not doing ab initio training in an eVTOL. You are a commercial pilot when enter on device. So it's almost you're essentially going through a type rating when you begin to embark on that path of eVTOL. And as such, you know, a pilot, regardless of whether I'm piloting a 172 in ab initio, I can apply the same competency framework. I can't necessarily expect the same level of maturity. And the same goes equally for eVTOL, right? When you look at situational awareness, they're going to be flying at lower levels in higher traffic environments with buildings, you know, wind shear. They're going to lose GPS coverage because of blackout areas. The problematic there is going to be different, but what you fall back upon are still these competencies that we shared with everybody earlier on. Sunjoo shared, give you some insight at least to the competency level of it, and the underlying behaviors are really the areas that are assessed. So yeah, can be used.
Okay, 1 minute left for questions here, and I just have one final one for our industry partners, and that is, what advice would you give researchers on the most important and impactful research related to this topic? So if you get to tell us where to go, this is where would you take us?
In less than 1 minute.
Yeah, no, I need the really short version of it.
Well, personally, I would say to maximize your opportunities to engage the industry partner with what are your needs, what are your expectations and requirements. You will have access to research dollars, and it may be down certain pathways with guardrails, but exploring their requirements, their needs. Again, they don't speak the language of neuroscience, so they may not be able to articulate the sophistication of their needs. So you got to spend time with them. You have to spend time with them.
That was exactly the point I made in the slides that I passed on to WISA, that you really do need to get out there. There needs to be much, much more interaction to understand what are the practical issues of EBT and competency-based training, and just training in general. How does a simulator session take place? Who is involved? Who are the stakeholders? How does that whole process work? How are pilots being assessed? How does a briefing, a debriefing take place? Just all the practical issues, and it'll be a big eye opener for everyone. And I'm sure that can be arranged quite easily.
Oh, absolutely.
Mark, did you have anything you want the last word on that one?
Yes. So one of the areas that we're particularly interesting is today knowledge, which is also one of the competencies and part of the recurrent training when delivered, is focused really on aircraft systems. So in this cycle they'll look at electrical system. Next cycle they'll look at hydraulics, braking. So it's very much a knowledge base, and the content that's been developed over decades is tailored to do that. With the movement towards competency-based training, we're talking about behaviors. So somehow the content has to pivot from knowledge development to behavioral development. I think that's an opportunity for universities to help industry understand how to make that pivot, because it can't be just with PowerPoint slides that we do this, right? And then a behavior is also something to be developed. It's not something that you just learn and do and master immediately. So again, there's a challenge in terms of mastery of behavior. I think there's an opportunity there.
A huge thank you to everyone who has joined us today and for all of those participating. Thank you to our researchers and industry partners. I've been asked for everyone to give us a big smile because I believe they want to take a screenshot. And now I'm going to put in a plug for our next WISA webinar. So please join us again on Thursday, January the 6th at 11 a.m. for our second WISA Talks. It is data analytics and optimization, and it's hosted by WISA Associate Director of Economic Pillar, Dr. Shir Shao. This webinar will dive deep into how data are collected, analyzed, and can be used to form best practices in aeronautics, such as aeronautical decision-making, safety, operations and scheduling, and optimized routing. She will be joined by researchers and industry partners from NavBlue, Nav Canada, and one or more to be confirmed. The invitation to this webinar will be hitting your inboxes shortly, and we hope to see you then. Thanks to everyone again, and hope the rest of your day is great.